Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 60, we will talk about shared mobility, and this is the last lecture in module 12 and also the last lecture in this particular course. So, the different concepts that we will cover will be on the background of shared mobility, then shared mobility classifications, on-demand en route ride services and their evolution, and then components and processes, and then algorithms, the different types of categories of algorithms, for example, searching algorithms and assignment algorithms. Then we will look into the search pricing, and then finally simulation modeling for integration with land use transportation models. So, looking into the background of ride sharing, of course, ride sharing evolved. The term actually is not the way, the definition of ride sharing actually encompasses lot of different things, and so basically there is when a particular ride is being shared, we can call it ride sharing, but right now ride sharing is refers to a particular group of services like the ones provided by Ola in our country or Uber internationally. So, this kind of services are usually referred to as ride sharing, but actually there is a lot of differences in the way the term has been used. So, this particular kind of services evolved during World War II, and initial form was in form of car sharing clubs during 1942 to 1945. So, this was the phase one of this particular system, and these were like a self-dispatching system, and people used to get the data through bulletins and all, so that when somebody is going somewhere, so some people can share the particular vehicle. Then the second phase of ride sharing started when there was energy crisis during the 1960s. So, there was very little oil, so people were saving oil by traveling together. So, there was a lot of carpooling happening at that point of time, or van pooling. So, employer or government sponsored van pooling and carpooling actually happened. So, this is also known as casual carpooling. So, this is another form of ride sharing. So, then finally the basic form of formal ride sharing started during the 1980s, and through 1997 we see this form where organized ride sharing schemes where telephone based ride matching was started. So, this kind of system was formally introduced. Then finally during after 1999 we have this online ride matching services. It could be like a taxi service, or it could be some other form of ride matching services which actually started. And then finally the format of ride sharing that we are more aware of right now, or the way we identify ride sharing, it actually started after 2004, and these are called technology enabled ride matching, and these are real time ride matching services which have been they came in different form, of course, and this started during 2004 onwards. So, what are the different kinds of shared mobility classification? How we can classify it? So, one could be a self-service model. That means the individual has to run the service or use the service on his own. Then there is a rental service model, and then there is public transit. So, these are all shared mobility options. So, public transit we will not discuss, because you know public transit, it could be offered by both government and private operators, and it's totally different from the ride matching services as we perceive it. So, in self-service model, this includes services offered among organized group of participants and renting out of privately owned vehicles to people with or without membership. The self-service models can be further categorized into three groups, like it could be car sharing, it could be bike sharing, or it could be scooter sharing. So, it is a group of people, they have their own vehicles and they share the vehicles amongst themselves, or that means there is a format where a group has pulled in money to buy a few vehicles which is shared amongst them, or it could be called as a car club, or if it is done through a company, then it's a platform where one vehicle is offered to multiple people. But then in rental service models, this includes pre-arrangement in hiring of a cab as well as on demand booking. So there could be pre-arranged hiring of a cab, or it could be a demand booking, and it could be divided into two groups like traditional ride sharing and real-time mobility. Like traditional ride sharing is whenever you are sharing a particular, that means like a taxi services that we used to have. So this is a traditional ride sharing where you can call in a taxi and so on. And then there is real-time ride sharing as well. So this is known as real-time mobility. So over here, the companies actually is not directly involved. So companies can facilitate, that means you have your own ownership share of a particular vehicle. In that way this can work, or but over here you don't own the vehicle, the company actually rents it to you. So in this particular image figure, you can see that we start with shared mobility, then we have this three parts: self-service models, public transit, and then rental service model. In self-service models, we have these three kinds: car sharing, scooter sharing, and bike sharing. So car sharing could be with ownership, and within that there is fractional ownership because you are sharing it with others, or there may be or may not be ownership. This is one. In bike sharing, it could be public bicycle sharing, it could be closed campus bicycle sharing, or it could be peer-to-peer bicycle sharing. So this is also sort of a self-service model. That means I will go, I will use a bike, and then I will go. Nobody is going to help me. But there is a online platform which is behind, which will help me to use that particular bicycle. Whereas rental service model, there is something called ride sharing, and then there is real-time mobility. So within ride sharing, there could be acquaintance based, that means amongst the people, this is a group of people. It could be based on an organization, that means the organization can organize its ride sharing, or it could be ad hoc ride sharing. Whereas in real time mobility, we have pre-planned services and on demand en route ride services. That means there could be, you can book your ride beforehand and the vehicle will come to you, or it could be on demand en route ride services, which means it would arrive at you on your, whenever you demand it, it will arrive to you, and then you will get a service. So on demand en route ride services is the one which we see as the normal Uber or Ola, this kind of shared mobility service. So our lecture will be mostly focused on this kind of ride sharing, as this kind of ride sharing techniques or technology. So on-demand en route ride services is an online platform which tries to optimize the demand for casual, one-time and irregular trip for relatively short distances, requiring almost a real-time response during the course of journey of its participants, both for the riders and the drivers, through specific ride matching techniques. So there are two stakeholders, one is the rider and one is the driver, because the driver is already in the vehicle, the rider gives a request and the driver is matched with the rider, and that is why it is called ride matching, and then they go to a particular destination as per the demand of the rider. So this is this happens once, that means this rider is not going to continue the same ride with the same driver. It can happen, but it can happen just by chance, but there is no formal way to do that one after another. So it's only for one ride. It's a irregular trip for and it's relatively short distance. It is not like a trip will last for hundreds of kilometers, and it requires a real time response, because as soon as you give a request, you are assigned a particular vehicle. So this we have categorized as on demand en route ride services. So on-demand en route ride services could be again divided into three kinds. One is the ride sourcing services, one is ride splitting services, and the other is real-time ad hoc services. Now ride sourcing services is the one where we have got a driver pool. That means there is a pool of drivers, and then there is a ride sourcing platform, and the job of this ride sourcing platform is to provide a platform where the drivers can register as well as make themselves available. Whereas there is a smartphone application which is used for booking and giving ratings for both drivers and passengers, and of course settling the payments and all. And this smartphone application connects the rider with this ride sourcing platform, and where the ride sourcing platform offers a multitude of vehicle types which could be used for a particular trip or a particular service. So this is basically ride sourcing, because we are using a ride sourcing platform from where there is a pool of drivers. We call it ride sourcing. Ride splitting is when ride splitting is a form of ride sourcing where riders with similar origins or destinations are matched to the same this TNC driver. So this is the driver who is coming from this ride sourcing platform. So this is TNC is the transport network company. So in that sense, this driver and vehicle in real time is actually assigned, and the ride and costs, the total ride is and the cost of that particular ride is shared among the users who is all going towards the same destination. So people, they may not go to the exact same destination, they may not be from the exact origin, but there is a cluster of origins nearby and a cluster of destinations nearby could be combined, or it could be along the way as well. Some of the destinations could be along the way. So that kind of algorithms are actually designed to determine to split a ride. So that's why we call it ride splitting. And finally, there is real-time ad hoc services, and what it means is it incorporates flexible routing, that means flexible scheduling, or both, and they target commuters primarily connecting residential areas with downtown job centers. So what they do is like this shuttle services provided in India. By that means you can demand a particular service that you want to go to office at a certain time period of the day, and accordingly a bus will come and pick you up and they will deliver you to that particular location. Now you will share the ride with many people, so automatically your cost will come down, but at the same time there may be a new request coming along the way, so the bus will divert from the route and go and pick up passengers from that particular route and then take you to that particular destination. But the destination more or less remains same. So this is called real-time ad hoc services. Now, looking into the evaluation of this kind of services, the one we are more interested in is the ride sourcing services. Among this en route, this group of services. So ride sourcing services started with this on-demand en route services. Within that, the ride sourcing part started with Zimride, and so this is the first. Logan Green and John Zimmer were the founders. So they were the initial eventually they started Lyft. So they started Zimride at the beginning, and it was a ride sharing platform, but it didn't get too much popular, and this was a outcome of academic research. And then using this particular ride share platform idea, Uber Cab started. So this was the first instance when Uber started their black car limousines in San Francisco. And then this was around 2010, and then we also see the launch of Ola cabs in India during more or less the same time period. And then the owners of Zimride, or the founders of Zimride, started Lyft. So this is another very popular ride sharing service in the US, so and also in other places in the world. So this Lyft was launched in 2012. During the same time, UberX was launched. So this was another form of the same ride sharing service offered by Uber. And then Zimride was sold, and then Uber was also launched in India during 2013, and finally during 2014 we have Lyft Line and Uber Pool, where we also started where this ride splitting services were also started. So this, you can see an evaluation of the different ride sharing or shared mobility services, particularly for vehicles. So the different components of this process, more or less you have all used this service, most of you, and you know the different steps. So still I will just touch upon those. The first step is a passenger sends a ride request to a ride sourcing server, and the second step is the ride sourcing server generates a choice set which consists of a ride alternatives with different vehicles. That means you get an option to choose different kinds of vehicles. You may also see their cost, and then the ride alternative is referred to as a product or a vehicle type, and this is the choice set, and this choice set is also known as assortment. Now, in step 3, the passenger has the option to choose one of these products based on whatever he has been notified, and he can also reject all this product saying that, well, that waiting time is too much, because this assortment actually gives you the estimate of price as well as the arrival time estimate, like where the exact vehicle is and when it will arrive and how much time it will take. So a customer can also reject based on his threshold for waiting, or even if its threshold for cost is exceeded. So he can also reject the ride as well. So this becomes fundamental components which needs to be considered when we design a ride sourcing service. That means when we try to balance between supply and demand, of course, if demand is more, then waiting time increases because the supply cannot match up that kind of demand, and also the cost increases of the system, because when there is less amount of vehicles in the system, then automatically there is more demand for it, so people are willing to pay more. So that means eventually people have to spend more cost. So there has to be a fine balance, because if there is too much amount of waiting time, then people will eventually leave and don't use the service. So that balance is required. But the problem is from whose perspectives we will look into this particular balance. Is it from the perspective of this company who is more focused on making the maximum number of rides, or is it based on the number on the driver who is trying to get as many rides as possible, or he wants to be continuously engaged in his vehicles, or it is from the perspective of the the user who is actually waiting for that particular vehicle and has to also spend the money for that particular ride. So there has to be a fine balance that will be has to be determined, and accordingly supply and demand of this ride sharing services also needs to be determined. So finally, once a person gives his choice, the ride sourcing server sends a confirmation to the passenger, and then the service is confirmed, the vehicle arrives and the trip starts. So there are two basic groups of algorithms that are used in this kind of services, and both these services are we can use it for ride splitting, ride sourcing, and so on. So this kind of algorithms, these two groups are searching algorithms and assignment algorithms. Now, searching algorithms actually provides recommendation to the riders as well as the drivers regarding convenient pickup location. Then it also shows the hotspots, like where there is more likely chance that a driver will get a ride. And this information, actually the way the information is provided, actually also increases the matching efficiency between drivers and riders. So the first group of algorithms focuses on how the information has to be provided, because the information, depending on the information, the matching happens, and that matching is what we are trying to achieve, to increase the efficiency of matching. And then there is the assignment algorithm. That means once information is there, once information is there, we have to do the actual assignment. That means a particular rider is waiting, and the driver, a free driver is there in the system, or a driver is expected to be free within a certain amount of time. How do I match this to? So there are several algorithms that are also utilized for matching these two stakeholders. So for example, we will discuss this algorithm. So primarily we can say the nearest driver who is available from this particular rider or his location of his pickup point, that could be assigned. But if I do the nearest driver assignment, then there is also the question of maybe that based on the particular amount of demand, there could be and the destination of this particular user, it may have been better to have this driver assigned to somebody else. So you see that it is not a decision which is has got only one stakeholder, where the riders and the drivers distance is the main criteria. If I want to look into the overall system, then I have to choose other criteria. In addition, these companies, these ride matching companies, they also have other criteria, like for example, a driver is overworked, so he may be assigned a certain kind of trip, or a driver wants to go back home, he would be assigned a trip which goes back towards his home. Or it could be like a driver whose rating is very poor would not be assigned to a rider who have a very high rating. So there could be so many criteria for assigning. But if I look from the urban planning perspective, so the question becomes, will I optimize for this particular assignment by just measuring the travel time between these two, rider and the driver, or we will look into the overall city's supply and demand and then try to optimize. So both these processes are responsible to affect the utility of the primary stakeholder, that is the rider and the drivers. But the utility of the secondary stakeholders are also considered. So ride matching companies and the local governments are also affected in this particular process, like I was saying. Like the kind of information provided affects the particular company or even the government as well. For example, if I am providing information and then what happens, the information changes, then it has got a certain other effect. That means I unnecessarily provided the information, because by the time a person use that information to do an activity, that particular effect has of no use. So this kind of situations may arise, and some information be actually negative for some other particular when we consider the overall city's perspective. So when we look into searching algorithms, searching algorithm matches the riders and drivers and assign the suitable driver to a rider. So there are two approaches. One is the shortest path approach and the other is the optimization based approach. I was telling about both this. So in the shortest path approach, the shortest path based on time and cost is estimated through existing or novel algorithms, and the driver rider pair with the least cost is assigned to conduct a trip. In the optimization based approach, the optimal rider driver pair is determined using certain objective functions, and we optimize those objective functions, and it depends on the goal of the decision maker. It could be depending on the perspective of the rider. That means the goal could be maximize the number of rides for each driver. The goal could be reduce the waiting time for a rider, or it could be maximize the total number of ride matching. That could be the goal for the operator. And for the local administration, it could be the total amount of kilometers traveled should be less. So that means if I want to reduce the waiting time of a particular person, I may have to travel more. Whereas if I look into the city's perspective, if I want the closest, I would like to make the matching in such a way so that overall the city's the total travel time reduces. For example, for this, if this one vehicle, suppose we have got this vehicles and then I have got a rider over here. So if I match these vehicles over here and then there is a rider over here as well. So the next rider over here has to be matched with this vehicle. So this plus this, actually these are two distances. So if I add them up, will probably be higher if I would have done the matching in a different way. If I have put this rider with this person and overall this person could be also matched with this, then probably it may give us a better solution. So what I am trying to say is that means the shortest path solution may not be actually leading to a global it may be not the shortest distance for everybody. So that means if I want to achieve shortest path for one, it may actually lead to a higher distance for somebody else. So that is why we need to look into also optimization based approaches. So optimization is again could be done in different ways. We can have an optimal algorithm. This algorithm can be developed with specific parameters to determine rider-driver pairs, and the pairs can be matched in such a way that it optimizes certain parameters. Or it could be some sort of a simulation-based optimization, where optimal rider and driver pairs can also be determined through simulation, and we have multiple iterations, and those are conducted and we converge to optimal solution. We also do have of course, we do have a particular objective function, but the objective function is looking to is done for the entire city for a certain time period, and then we actually get to a particular cost. Whereas when we have a standard single optimal algorithm, then automatically what happens, it may match for that particular time period, but it may not have match for the entire day's overall cost. So this could be two approaches. So we also have got searching algorithms, and searching algorithms are responsible for providing recommendations to the driver as well as riders. So again, there are two approaches. One is the probabilistic approach. In the first approach, we determine the probability of finding a driver or a rider in a specific region, and for that we can also develop models, and these models can actually predict that okay, there is likely chance that if you go to this particular point or pickup point, then you will get a driver, or vice versa. So this is a probabilistic approach, and over in this kind of models we determine utility of an area for a particular and we also estimate the willingness of a rider or driver to wait in that particular area. So these are the things that are considered when we do a probabilistic approach. And in the simulation approach, we also determine certain it could be a strategy based approach or it could be a algorithm based approach. And in strategy based approach, we can have certain strategies like certain strategies for information dissemination, like we show the rider hotspot, and like for example we give the drivers can see in their app that these are the areas where there are certain more demand, so these are called hotspot, and drivers can decide to go there. Or it could be a prescriptive pattern. That means there are certain algorithms which will inform the driver, okay, you move towards zone A, where you will be more likely get a passenger. So it could be a hotspot, it could be some place in between as well, where there is a more chance of getting a passenger compared to his current location. So this actually helps him to decide, should he, after dropping a passenger, should he wait at a particular location or should he go and look for a particular customer. So the normal process is when a driver drops off his passenger, he actually may stand there if he feels that he may get a passenger over there itself. But if he feels that there is less chance of getting a passenger at that particular location, he will move a bit and he will go towards those points which he feels from his experience there is a likely chance to get passengers. But the thing is, it is not the experience is of course experience is important, but sometimes the experience and information both has to be matched. For example, if the based on estimation of probabilities or data for previous days, the right sourcing platform can also predict that these are the locations where there is more chance of getting passenger, and actually it can give a prescriptive instruction saying that okay, you move towards zone A, then you will be able to get a passenger. So again, the overall target is to reduce the or increase the number of ride matches, or reduce the total amount of increase the number of trips, or reduce the overall passenger kilometer or overall amount of money that is being made. So based on the objective, we take these decisions. So algorithm based models are where algorithms are developed to relocate the drivers, and this could be evaluated using a simulation framework. So we can propose a few algorithms, or we can propose a few methods, and we can then do a simulation, and instead of using a mathematical optimization, we can do a simulation based optimization, or we can do a simulation which helps us to determine what would be the effect when this kind of information is given. So usually this approach is mostly adopted from a prescriptive recommendation framework. So when we give a prescriptive framework, then we can run a simulation to see what effect it really happens. So actually these categories of this searching algorithms and all, there have been quite a few research in this area. I have not detailed the different papers or the different researchers who have developed this kind of models, but this in this particular lecture we are more or less touching upon the different broad strategies that are used in this kind of services. So finally, we come down to search pricing. Whenever the ride matching companies find that there is disequilibrium in terms of demand and supply, that means in certain locations there is a lot of demand but the supply is less, then they introduce something called surge pricing. Now this works in two ways. That means the drivers becomes attracted to go towards these particular locations because there they will get more money, and that also means that the riders who are waiting at those locations has to pay more money. So this has got two perspectives, and the second perspective is that because drivers are going to those particular area, the waiting time of these people who are waiting or asking for a ride actually reduces. So the overall waiting time also reduces, and that will actually so people will get a better level of service. So that is also what is beneficial. So that means at one point the drivers are able to earn more money, and then the other point is the riders would be served at a lesser amount of time. But the negative things that also arise out of this is the people have to pay lots, sometimes quite a bit of more money, and sometimes drivers are unable to get passengers when they reach this particular region, because at that point of time the demand has gone, or the fleet utilization actually suffers because of this particular problem, because there of this imbalance, because most of the drivers, instead of serving the other particular zones, like for example there is a mild peak over here but there is no such pricing, so the drivers from this part also goes towards this particular zone, and automatically this part would be left unserved. So over here so there it also fleet utilization actually reduces. And then there is negative externality on the city's infrastructure. That means there is a lot of extra miles that are being traveled because of this kind of redirecting the vehicles towards a particular zone, and that actually increases the total greenhouse gas emissions. So that may also play a role in determining how the information like this kind of information of hotspots should be provided. Now I will just touch upon Uber movement data. Like it's a private company, but at the same time Uber provides certain amount of data, and similarly Ola also offers some amount of API access from where you can also get an estimate of what kind of travel times, waiting times, and is there for a particular area. And this kind of data actually helps. These are information based on the huge number of trips that are conducted by this particular company. So this doesn't have the data on both the individual as well as the driver or a particular car, but their aggregate data is provided on how many rides are being done at what time of the day, from where to where rides have been done, and we can track car travel times between any 2 points in a city at any time of the day, and commute patterns can enable, and this kind of commute patterns which are there, this will enable decision makers to plan for efficient ride sourcing, resource allocation. So if you see the ride sourcing services are growing at a very fast pace. In developed countries it is growing around 20% per year, whereas in India maybe a little bit less, but still it is growing at a very fast pace. And then in India maybe the rate is fine, the rate is almost same, but the rate of adoption is much lower than developed countries, but we are growing faster. And this kind of but the problem is these services are provided by a private entity. So even though we can estimate the demand from a travel demand model, like how many people wishes to go using this kind of services at a particular time of the day, but we have no idea about what kind of supply this particular companies provide. So this kind of data actually will help us to ascertain some amount of that, but that is still not adequate. So how can we integrate this kind of services in traditional land use transportation models? Because that is what is our primary goal. And our goal is to reduce the total amount of travel, reduce emission, reduce vehicle kilometers traveled, or also to provide a less amount of waiting time for the passengers, like reduce waiting time for customers. And if I also look into the perspective of the drivers and also the companies, then we have to also increase the number of ride matches for drivers, or they have to make certain amount of profit. So how do I integrate this kind of system, which is a privately supplied system, into our entire transportation supply in a particular urban area? So because in transportation supply, we also need to like when we are doing assignment, we know that okay, there is a vehicle in personal vehicle could be directly assigned to a route. When we are talking about transit assignment, of course, we didn't cover transit assignment in detail, but we can understand that that means a particular there is a demand for a particular stop, and a bus will come and it will serve that demand. So depending on the amount of bus service over there, we can understand how much demand could be served, and accordingly the demand is influenced by that kind of service. But because we have no information about how, and because public transit is provided by private companies as well as government companies, we still have got information about, because we are putting this GPS system in buses, we have information about the buses and when they are traveling, when at which locations they are, and so on. But because this ride sharing is offered by private companies, we don't have this kind of information. So we need to develop certain simulation models which could be integrated within our land use transportation model as auxiliary models, where we can evaluate the total demand for ride sourcing services, and also the demand, how much of the existing travel demand that we ascertain from our modal choice models could be served by this kind of supply, and how to do this supply and what sort of vehicles are required to achieve a certain kind of optimal solution. So we see that in this particular image, we have travel demand for as per time of the day. So this comes to demand prediction. Along with that, we have also data on pickup drop off from TNCs, like the ones that they share. We can understand which are the hotspot, and based on this machine learning algorithms, we can also predict that okay, at different times of the day how the demand varies at different time periods. But this depends on supply. That means a person would be only served if there is a vehicle to serve it. So this demand actually shows us that number of vehicles that are being, this demand is estimated based on number of trips that are already being served. So that is something that means it doesn't take into account trips which are not served. So that is where we need to do this estimate of what people want to travel. And then after that, like this is based on stated preference experiment, we can determine how many number of people would like to travel for this kind of services, and then based on our simulation we can determine what would be the optimal number of vehicles to supply for this particular urban area. And that also will also determine the waiting time actually experienced by different riders, and that waiting time will again influence that particular rider's mode choice. So these things are linked in this way. So simulation, and we have to this hotspot and determination has to be done, and then in the simulation environment this kind of data can come in, and we divide the entire area into different grids. It could be hexagonal grid, it could be, usually we use hexagonal grids, that is easier to solve movement patterns between different grids. And then we form this grids where we determine the demand for each of these grids, and then we also determine the number of vehicles which are free to serve this particular demand in this particular lattice or this particular grid or in other adjoining grids. And then we can program different various vehicle movement strategies, like how a free vehicle search for a passenger, will it wait there or it will move at a certain location, and based on that we can determine that the appropriate ride matching algorithm, and we can match a vehicle with this particular demand. So this evaluation of vehicle transition strategies we can also evaluate by simulation, and then we determine based on a demand optimization model the total demand and supply is matched, and from there we can determine the optimum fleet size. Now objective functions for this kind of optimization model could be total number of trips made and lost, it could be distance traversed, it could be time taken by everybody for all passengers, it could be riders and drivers waiting time, we reduce both of their waiting times. So it could be several objectives, or it could be a group of objectives which we can minimize for an urban area, that will give us a fleet size for an urban area. And this will also, this fleet size eventually helps us to determine that okay, what would be the waiting time for passengers and also cost for passengers to some extent. That actually helps us to determine mode choice and eventual link assignment. So these are some of the references you can study. To conclude, this lecture gives an overview of the on-demand en route services and particularly ride sourcing services. Ride sourcing services are one of the fastest growing modal alternatives in Indian urban areas, and its integration into the urban land use transportation planning process is pertinent. So, around 20 to 27% of mode share is already there in developed countries. So, we are going towards that or even more. Supply in urban areas, of course. And then supply of ride sourcing services is, however, controlled through transportation network companies, which are private entities not bound by city authorities and operate as per their own mandate and objectives. So, that is the issue that we need to take care. And so, there is a need for a model for both demand and supply of these services at the urban level to not only ensure adequate supply at different times of the day, but to determine their appropriate fleet size. Thank you.